To begin with, we are going to be talking today about I can find roots of real numbers. So what this means is we're taking the roots, not just square roots, but also like cubed roots, fourth roots, fifth roots, and so on, of real numbers. The real numbers being that we're specifically talking about those numbers that fit into, if you remember that diagram we made at the beginning of the school year that you all hated me for, where it had a box and then inside were two boxes and then we had a bunch of circles in them, where we talked about real numbers. So then more to do with the actual real numbers that we're talking about. When we say powers and roots are opposites of each other. They're opposites, which means that they're inverses, which also means that they can undo each other. So what this table is showing is that if you have something like a to the third, so if we have a to the third here, it equals 125. So what they're saying is 5 times 5 times 5 gives us 125. Well, what it's also saying is that if we take the cube root of 125, so the cube root being something like this, where there's a 3 on the outside here, if we take the cube root of 125, it's going to equal 5. So that's an example. They are opposites, they're inverses. This is taking a big number and making it into a small number. This is taking a small number and making it into a big number. So then specifically what we're talking about is if we look over here at this symbol, it looks like the division symbol, but it's actually called a radical symbol. So this is called a radical symbol. So then with our radical symbols, we're going to have a number here on the outside. This number on the outside we'll just label as n right now as a variable, a number that we don't know yet. We're going to label that as our index. So that outside number there is called our index. And then our inside number, I'm just going to give it the variable b for now. That inside number is our radicand. Radicand versus radicand not. I'm so funny. Okay, so these are important to know because then they'll help us with our chart down here. So then looking at our chart below, what they're saying is that if n is even, so when I'm talking about n, I'm talking about that outside number, right? So that number that's on the outside of our radical symbol. So if I had an even number like 4, let's say. 4 is an even number. We have 2, 4, 6, 8, all evens. Another one, if we took like, what's 2 times 2 is 4. Okay, if we took 32 as our number on the inside. So right now, 32 is greater than 0. It's bigger than 0, it's a positive number. Also, our n here is even. This is an even number. Whenever we have an even number out there and a positive in here, that means that we're going to get one positive and one negative. And we're talking about our answers there. One positive number, one negative number. Then that also means what you can do is you can put this little symbol there, plus or minus. That means positive and negative. On the other hand, this time we have b that's less than 0. So if we were to have our even number index 4 out to the side, and then we have a negative 32 on the inside, we don't like negatives underneath. This is because, like, if you took negative 2 times negative 2 times negative 2 times negative 2. This is just an example here. You don't actually have to write any of this down. So if we were to take this, then if we multiply these together, we get a positive 4. Multiply here, we get a positive 4. Multiply there, we get a positive 16. So it ends up being a positive number, not a negative number. That's our key here. It's not a negative. So essentially what all this means in the end is that we have no real numbers. So since we have no real numbers, this means, we'll learn this more later on in the week, that we have non-real numbers or imaginary numbers. I know you're really excited to learn about the imaginary numbers. So for now, we can't answer this any further. Later in the week, we will be able to. If we were to have an odd number for our n, so if we were to have something like 5 for the outside and then the fifth root of 32. So here again, our b is bigger than 0, and this time our n is odd. 5 is odd. 1, 3, 5, 7. So then what this is saying is, for an answer, what we would end up having is 1 positive as our answer. We're only going to get a positive out of this. We will not get a negative. Then on the other side, over here, if this time we have b is less than 0, so if we have fifth root of negative 32, so this time our b is less than 0, so it's that negative number. This means we're going to get 1 negative as our answer. We're going to have 1 negative as our answer. This is because here again, if we look up here instead, and this time I show you an odd number of 2, so like -2, -2, -2, -2, and -2, and they're all being multiplied together. Well, if you multiply these, you get a positive 4. Multiply these, you get a positive 4, and then you have a -2 hanging out. Then you multiply these, you get a positive 16 times a -2, which is then going to give you a -32. Whenever you have an odd exponent, you will end up with a negative if your inside number is negative. So that's why we will end up with 1 negative as your answer. So then moving over to the right now. So this time what they're telling us is, no matter if it's even or odd as our n on the outside, our index on the outside, doesn't matter. If b is equal to 0, so if we had like fourth root of 0, well, let's think. 0 times 0 times 0 times 0, what does that give you? 0. So 0 is just your answer. And same thing if you have an odd number. Because again, 0 times 0 times 0 times 0 times 0. Doesn't matter how many zeros you have, they're still all just going to equal 0. So no matter what, if you have a 0 on the inside as your radicand, it's going to be 0 as your answer. So then going down to our examples here, if I have a plus or minus out in front, I'm going to keep that plus or minus sign for my final answer. So I'm just going to rewrite plus or minus here. Then what I'm going to do is I'm going to take my original problem and I'm going to split it up. So what I mean by that is putting a square root of 25 times, because when they're right next to each other, it means they're being multiplied, times the square root of x to the 4th. So now we have plus or minus. The square root of 25 just gives us a 5. So then we're done with that. Now we have to multiply it by, this time we have x to the 4th. Well, out here, whenever you have a regular square root symbol, there's the invisible number 2 out there. So with that, we want to end up canceling a 2 in here. So let's think, if we have x to the 4th, but we want there to be a 2 here, 4 divided by 2 gives us 2 and 2. So then what can happen is this radical symbol here, that can actually just cancel out. We can be done with that as well as this squared over here, because this imaginary 2 out there cancels with our 2 over here, just leaving us with x squared. So that means for a final answer, we have plus or minus 5x squared, and that ends up being our final answer. If we go over to our next problem, this time we have a floating negative out in front. So if we have our floating negative out here, we're going to keep that. Then my imaginary number out here is a 2. Whenever you don't see something, imaginary number is 2. Well, let's look at this. 8 divided by 2 is what? 4. So let's draw our radical symbol as normal. Underneath, we're going to have y squared plus 2. We're going to make it to the 4th. This is because 8 divided by 2 gives us this 4. So we're going to have a 4 there. Then I'm going to build some more brackets just so that it looks cleaner. And then we'll have our squared out here because 2 times 4 gives us our 8 up here. So now, once you're to this point, now you can say, okay, so my 2 here is going to cancel out with my imaginary 2 out here. So this whole radical symbol just disappears, leaving our final answer as negative y squared plus 2 to the 4th. And that ends up being our final answer. If we scoot over here over to example 3, this time it changes up a little bit on us. So this time we have a 5 up here instead of no number, meaning that invisible 2. Well, this time what we can do is we can say, okay, let's still split it up. So we have the 5th root of 32 times the 5th root of x to the 15th times the 5th root of y to the 20th. So then from here, we can use our calculator for this part with the numbers. So the numbers, we can use our calculator. For this, I'll probably have to show you in class, but I'll just talk through it. There is a way on our calculator where you can take the 5th root of a number or the 6th root, 7th root, doesn't matter. And the calculator will figure it out for you. For now, until you get into class, I'm just going to leave it as telling you that the 5th root of 32 is 2. So now we know that this part is 2. The next part we have is this 5th root of x to the 15th. What I'm going to say here is, okay, let's still take our 5th root, but we want to cancel this 5th root out. So 15 divided by 5 gives us what? 3. So that means now I can cancel out this 5 and this 5, leaving me with x to the 3rd. And then our last part with this, we have the 5th root of y to the 20th, but we're saying what's 20 divided by 5? Well, it's 4, so we'll have y to the 4th to the 5th. That way that 5 on the outside can cancel with this 5 on the outside. So then what this is telling us here is that we end up with, I'm going to write it way up here. I apologize, but I'm running out of room here. I'm going to have my 2 from over here. Then these 5's canceled out over here. So that just leaves me with x to the 3rd. And then my 5's canceled here, just leaving me with y to the 4th. And this ends up being our final answer. Now our last one, this one's a little bit easier. If you look at this one, hey, we have a negative underneath. Whenever we have a negative underneath, we're going to have to look at our columns here where we have that negative. So it tells us if b is less than 0, which we have with -9, and this outside index is an even number, which it is, that invisible 2, that means we end up with no real numbers. So because we have that invisible 2 out here, and we have a negative on the inside, our solution is no real numbers.